Hi, we're going to talk about how to deal with these derivatives and integrals for exponential and log functions that are not our normal natural log and e. So this says for a b greater than 0 and not equal to 1, we have that the log base b of the absolute value of ux is u prime of x over ux times ln of b. And that the derivative of an exponential function with base b and power u of x is equal to the natural log of b, and that's in parentheses, times b to the ux times u prime of x. And finally, for the integral, we have the integral of b to the x dx is equal to 1 over ln of b times b to the x plus the constant c. When we're working through these problems in the homework, it's pretty much plug and chug, with the occasional u substitution to write it in one of these forms. So this is our only form for integration. So if we see anything that doesn't look like that, we're going to have to do u substitution so that it does look like that. All right, let's try it on a problem. Let's try to integrate x times 3 to the x squared. And let's try to recall in a different color that we need something that looks like b to the x. And we do not have that dx. Both of these need a dx. All right, but we can make that. We just need to do some fancy u substitution. And let's do that in yellow. So if I let u equal x squared, then du is equal to 2x, and so dx. So du over 2 is equal to x dx, and I have an x dx in the problem, so I can just plug that straight in. So this becomes the integral of 3 to the u du, and then I need that 1 over 2 in the front to make up for this 2 right here. Okay, now I can just plug and chug with the definition. So that would give me 1/2 times, and now to actually take the integral, it is 1 over ln of 3, ln of the base, times the base to the power, so 3 to the u, plus a c. And then the last thing I would need to do, since it's an indefinite integral, I need to go back and replace this u with the actual x function. So this is 1/2 times 1 over ln of 3, 3 to the x squared, because that's what u is, plus the constant. And then the last step for MyMathLab to be happy would be simplify it a little bit more. So this is 1 over 2 ln of 3, just by combining fractions, times 3x squared plus c, and that would be our actual solution. Okay, so let's try it again for this mildly terrifying looking definite integral. The definite integral is kind of relief because that means that we don't have to go back and plug in x at the end. We can just switch our integral limits so that they match the u variable we'll come up with, and then integrate like normal. So the first question is, how do I know I'm supposed to use u substitution? And the answer to that would be to recall that the only way we know to integrate these is if it's in the form b to the x dx, and we do not have that. In this case, b would be 6, but our x function is negative square root of x, and we don't know how to deal with that. So we've got to use u substitution so that we end up with just like a 6 to the x or a 6 to the u. Okay, so let's let u equal the negative square root of x, because I don't want a negative up here when I replace this. Then du is equal to negative 1/2 x to the negative 1/2 dx. And x to the negative 1/2, that's 1 over. So that would be negative 1/2 times 1 over square root of x dx. And I want to move this over, so I need 2 negative 2 du is equal to dx over root x. And I have dx over root x right here, right, because this x is in the denominator, so this is dx over root x. So what I need to do is replace this guy. So I'll move him to the outside. I have negative 2, oops, I forgot a step. I need to change these guys in terms of u. So let's go over here and do that. If x is equal to 4, then u is equal to the negative square root of 4, so negative 2. And if x is equal to 1, then u is equal to the negative square root of 1, so negative 1. So now our integral goes from negative 1 to negative 2, decreasing limits of integration. Okay, so now I just replace my u's. So this is 6 to the u du. Remember, this x dx got replaced when I did this u substitution. dx, oops, du. Okay, so now just following the plug and chug formula on the very first slide. This guy, I just need ln of 6 times 6 to the u, and then no plus c because it's a definite integral. So this is negative 2 times 1 over ln of 6, 6 to the u, and then I need to evaluate that from negative 1 to negative 2. Let me erase this rude guy. Control Z. There we go. Okay. So just the plug and chug part now is all we have left. This is equal to 5 over 18 ln of 6. And you may be wondering how I got that, and I will tell you it's from plugging in negative 2 and negative 1. And I'm going to let you do that algebra on your own and make sure that you get this solution.